Thank you for the introduction. It's not as impressive as Dr. Izzat mentioned, but so over the years, those are my collections of my experience. And I hope what I can do for you guys today is to share whatever that I have learned along my journey. So for my PhD, my concentration was in food and beverage management. I believe all of us here are in hospitality and tourism management, right? So my concentration especially is in food and beverage management. For those who wants to collaborate with me after this, my minor for my PhD was in methods and statistics. It's just because I simply love statistics. Okay, so let me just share with you my whatever that I have today. Let me just share a window. Sorry, not a window. Okay, here you go. Okay, you guys can hear me clearly, right?
Yeah, sure.
Semua boleh dengar ya?
Loud and clear.
Do we have any international students today, or anyone that does not understand Malay?
I think for the time being, we don't have one. For the time being, we don't have one.
So it's okay if I use both language, right? I can if I can interchange between Malay and English, if that's okay with you people.
Yes, of course, Dr. Nadia.
All right, thank you, Dr.
Yeah. Right.
All right, so Dr. Izzat mentioned that I have around 30 to 40 minutes today for this sharing session with you. It's quite a crunch for me to be able to explain like the entirety of data analysis. That's like cramming 13 weeks of lesson into 30 minutes. But I'm not going to go over like each and every analysis, but what I'm going to do today is to let you know or to share with you my thought process of doing analysis. All right, so here we go. Let me ask you these questions first. What are your thoughts, especially for the students, especially for those who have not analyzed your data? What are your thoughts or feelings when you already have your data, when you have collected your data, and now you have to run your own analysis? Can somebody share with me?
Yeah, anyone?
Yep, guys.
Yeah, guys.
I know some of my students from 720, they're here.
Yeah.
So anyone wants to volunteer? What are your thoughts about running your own data analysis?
Confused. Puan Hayati say confused. It's confusing.
It's confusing, okay?
Yeah, I know. You know your students very well, the problems that they are facing, especially, in research, when you have intersections during data analysis, on selecting the right analysis. I think that's the feeling that students are having right now. Intersection and the junctures that they have ahead of them.
Okay, so moving along those words of from Dr. Izzat, I would like to ask, so when do you guys decide what analysis will you use for your thesis or for your research project? When do you decide this?
Students, you can use the chat box to answer Dr. Nadia Hanin questions.
Yeah, because it's a sharing session, so it's nice if we can have like a two-way communication instead of me just talking. So it's gonna be boring if it's like that.
Yeah. Please, we have answer. Muhammad Najmi say, after all the data has been collected, Dr. Nadia.
Oh, okay. Oh. That's quite late. At the initial stage, perhaps. Okay, Zulfikri. At the initial, at the beginning when we chose the topic. All right, okay. Early stage, yes. Yes, Ridwan, thank you very much. Okay, so basically you need to decide your analysis, or you can decide your analysis when you already have your research objectives. So this is where the analysis comes in, okay? When you have your research objective, when you have your research question, you already know your analysis. How do we do that? I'm going to talk about it later, all right? We will get to that. All right. So I know all of you have heard this term, garbage in, garbage out, right? You guys have heard this in your research methods class when your lecturers are talking about statistics. When you put in garbage, when your data is garbage, you're going to get garbage, right? So, right, because all of us here from hospitality and tourism think of data analysis like a cooking process. Okay, some of you are from a culinary background, right? Okay, so to me, data analysis is like a cooking process. Even if you have good data, even if you have collected good data, the wrong kind of analysis or the wrong kind of cooking style will still give you an output that belongs in garbage, okay, or that belongs in the trash can. So you have to select the correct analysis for your data, for the type of data. So when you collect your data, once you have your objective, right, once you have your research questions, right, you have already planned for data collection and you have already developed your instruments. And during this time, you already know, okay, whether it's going to be a multiple regression, whether it's going to be a logistic regression. Okay, I know some one of my ex-student came to me and said like, oh, I can't run this multiple regression, what's wrong with my data? Okay, the problem was that she had a dichotomous dependent variable, which, you know, if you have a dichotomous dependent variable, you would have to run a logistic regression. So that's why your multiple regression will not work. Okay, so you have to take a look at your data. You have to be careful about your instrument as well. So this is why I'm telling you that once you have your objective, you should have already have a vision about your analysis. Okay, so don't wait until you have collected the data, you have analyzed the, you have looked through the data and then decide your analysis. It doesn't work that way. Okay, it's going to give you a lot of problems. All right, so so students often come to me and say like, okay, I have collected my data, now what? Okay, it's just a bunch of numbers. I don't know what to do with it. All right, so first what you need to do is to plan your analysis. This is done earlier on in the during your proposal stage, and then you need to organize your data. A lot of students fail to do a step number 2. You did not organize your data. You expect that once you input your data in the SPSS is going to do every single thing for you. No, 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 it doesn't work that way. The SPSS is just a tool. Okay, so you decide what the SPSS is going to give you, right? Okay, what if you're not using SPSS, if you use Minitab? Okay, it doesn't matter, it's still the same thing, right? You can use SPSS, you can use Minitab, you can use ListRel, you can use R. It doesn't matter what the software is. It matters most how you understand the software. Okay, and then you run the analysis and interpret. So let me take you through my thought process when I have my data. All right. Okay, so this is a step-by-step process. It's very simple. Okay, so I know some of the students, they are overwhelmed with data analysis. Some of my students tell me that, oh, I'm not good at math, so I can't do statistics. It doesn't work that way. Okay, math has it has something to do with statistics, but you don't have to be good in math to understand statistics. You don't have to be afraid or get overwhelmed with your data. Okay, so let's go over the steps. First, you need to envision your analysis. So this is what I like to do when I have my data. I like to envision my analysis. Okay, so in order for me to answer my research questions, what should I do? All right. What can I do? How do I answer my hypothesis? How do I test my hypothesis? So I envision, okay, so first I need to run descriptive analysis, and then I need to run my EFA, and then probably my CFA, and then my inferential statistics. So what I do is I like to write it down. Okay, my steps. Okay, what are the steps for data analysis that I want to do for this particular project? I'll write it down. Okay. And then after you have planned, after you have envisioned your analysis in your head, you have to clean your data. Now that you have your data, right, you have to clean it. Okay, so this is the part that most students miss, all right? Why is it very important to clean your data? Because we do not want, when you have a survey, you have straight lining of your survey. This needs to be removed, okay? You know, some people, they just want to get it done and over with, so they just tick 3 along the way. If you have a 5-point Likert scale, they're going to tick 3 along the way. Or if you have a 7-point Likert scale, they're going to tick 5 along the way or 7 along the way. All right. So this straight lining of surveys, they need to be removed. Okay, so for those of you who use online survey or online data collection tools, right? It's it's better because you can actually measure, or you can actually filter their attention. So for example, if they don't pay attention to your survey and they complete a survey that was supposed to be completed in 5 minutes, and they completed it earlier, like 3 minutes, you can remove them. Okay, you can remove them as well. So all of this needs to be removed, all of this needs to be clean. And then some of you import your data from Excel, right? So let me just show you what my students do. And once they come, once they're stuck, they will come to me with and asking for solutions. So this is what they do. Okay. So this is what they sent me. You guys can see my Excel, right?
Yes, yes.
All right. Okay. So as you can see here, I asked them to clean the data, but what they did is like this. So how would I know which variable does this belongs to? So this is a not so clean data. The students, they did not organize their data very well. So when you come to your supervisor or when you come to other lecturers and asking for help, it's kind of hard because I don't know what this is. Okay, I don't know what statement is this. Okay, this is basically the instructions, and these are basically numbers, right? So you really don't know what this is. So organizing your data is very, very important. Let me just show you another one. A window, all right. Okay. All right. So this is a data that has already been organized. As you can see, it has its name, it has its one thing that these students kind of miss is that sorry, you can see my SPSS, right?
Yes, yes.
Okay, sure.
Yes,
All right.
sure. Yeah.
Okay. They did not put the label here. All right. So when you take a look at PE1, you would not understand what PE1 means, right? You don't know what is PE1, what is SI, what is CS. But because these are my students, I would know that CS is customer satisfaction and SI is social influence. Okay, that's just because they are my student. But what if you want to go to other lecturers and ask for a second opinion, right? So it's gonna be hard for you. So this is why I like to sleep on my data. I like to play with my data, and I like to organize my data very well. I have the names, I have the label put in properly, and I also have the values inputted properly, right? Okay, so this is a very crucial step. Don't forget about this. Okay, moving along with our presentation. Am I being too fast? Like, am I going over this too fast?
That's nice. I think just nice. Maybe,
Thank you.
yeah. Maybe students have something to say about the pace of Dr. Nadia Hanin's presentation.
Because I often receive comments that I like to talk very fast. So let me know if I'm going too fast. Okay. All right. So the next step is to run the easy analysis first. All right. When you get overwhelmed, always run the easy analysis first. Okay. I'm not talking about your instrument development or validating your instrument. So that's going to take you like your reliability tests and whatnot, right? So that's supposed to be in chapter 3. Okay, so but what we're talking about today is chapter 4. Okay, so run the easy analysis first. When you want to do your chapter 4, run descriptive first, okay, because descriptive analysis is very easy. So what you need to run is just frequency, percentages. If you want, you can run your mean scores and standard deviations, provided that you know how to explain them. Okay, so if they don't simply run analysis just because, oh, my senior run it. Okay, oh, because I saw in a different thesis it's like this. No, you have to understand your objective and question. Okay, and then you run your analysis. Because some of the students, when I ask, okay, why would you want to run SEM? Oh, because it's a better analysis. Who said so? Okay, never let anyone dictate your analysis just because they prefer that analysis over something else. Okay, there's always a reason why you need to run an analysis. There's always a reason why you run something. Okay, that is research, that is thesis. Okay, so run your descriptive analysis first. If you feel overwhelmed, just create the table and explain your respondents overview first. It's very easy, right? So half of chapter 4 is done. So you kind of trick your mind into being productive. So this is what you can do. Okay, you know, when you write your thesis, you're going to experience some thesis slump. Okay, you don't know what to write, you don't know what to run. Run the easy one first and then explain them. Okay, all right. And then this is what a lot of students often forget about, this is to run the assumptions for your inferential statistics. So assumptions depends on the statistical analysis that you choose. If you choose to run ANOVA, there's assumptions for ANOVA. But remember, some of my students here would know that they know, if they are in my class, they know that ANOVA is robust to violations of assumptions because it's a very robust technique. Okay, so you have to understand that. If you run, a lot of us here, we would run multiple regression. Please remember the assumptions for multiple regression. Last week, I received questions about normality tests. Okay, one of the assumptions for multiple regressions is your residuals needs to be normal, right? Normally distributed. Okay, and then a student came to me and said like, oh my God, my data is not normal. What should I do? What should I do? As you know, if you don't have a normal data, you have to transform your data, right, for multiple regression because there's no other ways to go around it. Okay, so if you don't have normal data, students will panic and basically not know what to do. Simple. Normality, you can test for normality in various ways. Okay, not only using Kolmogorov-Smirnov and Kruskal-Wallis, Kolmogorov-Smirnov test. You can also use the QQ plot, right? Your normality plot. You can also look at your histogram. So there's various ways to take a look at your normality. Why would you want to rely on a single test? Okay. So in my class, I teach like several ways to look at normality. All right. So don't panic. There's always solutions to your problem. All right. Don't forget the assumption. You have to run these assumptions because otherwise, you can't run the inferential statistics or your test will be invalid. Okay, the results will be invalid. Okay, and then after you have gone over the assumptions, you have report all your assumptions, you need to run your inferential statistics. You run the analysis, and then after that you simply report the analysis. It's very simple. The steps are very simple. Probably it's going to be very overwhelming in the first place if this is your first time running it, but as you go along the way and you clear your thought process about your data analysis, it's fairly very easy. I always look forward to chapter 4, okay, because it's the easiest part rather than chapter 1, chapter 2, chapter 3. Okay, chapter 4 is always the easiest part. All right, okay, so how do you manage your data? Preparing for data entry. A lot of students fail to do this, all right? They do not prepare for data entry. You have to have a master copy of your survey. If it's online, then you just simply print it, and you have to have a code for every questions. And then this code, make sure that it's easy for other people to understand as well, all right? For example, like screener, you put SCN, okay, or CRN. So we know that it's a screener question, right? Screen 1, screen 2, and then CSAT is customer satisfaction 1, 2, 3, 4, 5. Okay. This step is easily missed because some people think that it's not important. Actually, it's very important because if you are not confident with your analysis and you need help from others, then this is very important for other people to understand your data, right? Okay, and then students also often forget about data transformation. Okay, let me give you an example. If your variable, for example, you have an independent variable, and this independent variable, they have like 5 measurement items, right? And in your SPSS or in your data analysis program, there's only one place one slot for dependent variable. So how do I input all 5 items into the dependent variable? Oh my God, help. Okay, so there you go, panic again. You forgot to transform your data. Okay, so these 5 items, they need to be collapsed into a single variable. Then only you can move on with your inferential statistics. Okay, so basically these are the initial parts of the analysis that we often overlook because we just simply are too excited to run our inferential statistics. So we often overlook all this. All right, okay. So this is the part where probably some of you are waiting for. Okay, which analysis should you use? Okay, very easy, right? How do you choose an analysis? Based on your objective. First and foremost, it's always based on your objective, on your research question, or on the hypothesis that you want to test. Okay, and then the scales that you use, whether it's continuous or whether it's categorical and whatnot, and then how your data is distributed. Okay, so okay, so let's go over the research objective first. So basically, in our research in social science, these are the common objectives that we have. All right. So whether we want to compare means, whether we want to test associations or relationships, or whether you want to assess if one variable causes a change in the other variable. So that's your regression lah. All right. Ini aja research objective yang selalu kita ada in social science. Okay, you don't have other objective. If you want to look at trends, okay, so another objective, yeah. If you want to look at trends and you have a secondary data, for example, you want to look at trend for financial performance, then you know that your analysis is going to be trend analysis or ARIMA. You will use ARIMA, right? Okay, so but in social science, across the board, basically students will want to compare means, or to compare between groups, okay? Or they want to test associations or relationships. That's just it, right? So the possible hypothesis for mean comparison, associations, and predictives, it's on the slide. As you can see, for example, mean comparison, you want to see if the amount of salary differs according to level of education, or the amount of study hours significantly differ according to gender. A woman studied harder than men. Is it true? I do not know. So do a research on it, okay? And then if you want to test associations, which is very common, especially in our setting, you want to test if there's a relationship between service quality, serve qual, and positive word of mouth, all right? Academic success is significantly correlated to parents' income, or if you have a predictive purpose for your research, customer satisfaction significantly influence revisit intention, or salary can be predicted by working experience and education level. Okay, so I know these hypotheses are fairly common. You have read this, you have read about this hypothesis throughout your literature review and whatnot. Okay, so once you know that, once you know whether you want to do a mean comparison, then you will know what analysis you will use later on, right? Okay, let's go over the measurement scales. Whether you have a nominal scale, ordinal scale, interval, and ratio. Okay, so question is, where does Likert fall into? So some of the, so this is a debate by statisticians. Let's not go into it, yeah? I'll just let you know. So Likert scale is often treated as interval, okay? But if you go to FSKM or if you go to a statistician, they would say that this is an ordinal scale, all right? So actually, it is an ordinal scale, but in social science, it is often treated as interval scale, and it is okay. So do not go into that debate because we are not statisticians, right? Okay, so we treat Likert as interval in social science, so no worries about that, no problem. Okay, depending on your scale, you get to decide whether your analysis is going to be a parametric or non-parametric analysis. A lot of students, they are very afraid about non-parametric analysis because it's not as strong as parametric analysis. But I mean, like, if your research questions can be answered by non-parametric analysis, there's no harm in doing so, okay? So non-parametric, as you can see, it makes no assumptions of data distribution. If your data is abnormal, you can run non-parametric analysis. Usually based on ranks or signs. So basically, if you have an ordinal data, it's going to be non-parametric analysis. And it is definitely less powerful than parametric tests. Okay. All of this depends on your dependent variable, whether it's going to be continuous or whether it's categorical. Okay, and if your dependent variable has a continuous scale, like if you use Likert, it's continuous. Okay, if it has a continuous scale, if it is normally distributed, then you can run a parametric test. If your data, although the dependent variable is continuous, but it is highly skewed to the left or skewed to the right, or it's not normal, then you have to resort to a non-parametric analysis. Whereas if your dependent variable is categorical, and if it's ordinal, you can run a non-parametric test. If it's nominal, you run a chi-square, which is also a non-parametric test, right? Okay, how do you test for your normality? Various ways, okay? You can look at your skewness and kurtosis from your descriptive stats. Should be close to 0. Plus minus 1 is okay. And then you can run the test for normality, Kolmogorov-Smirnov, and also Shapiro-Wilk. Okay, your p-value should be more than 0.5, remember that? Okay, and then based on visual inspections, you can also determine, or you can also see whether your data is normally distributed or not. You can use a histogram, normal QQ plot, or box plot. Okay, there's various ways, all right? So don't rely on a single way. So what to check for normality? I'm not going to go over this. I believe Dr. Izzat will share the slides with you because I can't be going on to specific tests. It's going to take a long time. All right, so this is what to check for normality depending on your test. Okay, if you have an independent T, then dependent variable by group should be checked for normality. If you have a Pearson correlation, at least one of the variables should be approximately normally distributed. Okay, so and so on and so forth. Okay, so just now we have talked about your research objective, whether it's going to be a comparison, comparing between 2 groups or 3 groups or more than 3 groups, and whether it's going to be association, right? Okay, if you have an objective of comparing between groups, okay, group comparison, okay, if you want to compare 2 independent groups, if you only have 2 groups, then definitely it's going to be t-test. Okay, look at your respondents or look at your sample, whether they are interdependent on one another, whether it's going to be a paired sample T or it's independent sample T. Very easy, okay? If you are comparing before and after, are you using t-test or are you going to use repeated measure ANOVA? T-test, okay? Because there's just before and after. Okay, there's only 2. You are comparing before and you are comparing after. T-test, all right? So don't get complicated. Oh, I should run a repeated measure ANOVA. No. You're only running t-test, all right? If you want to compare between more than 2 groups, then definitely it's going to be ANOVA. Okay, it's going to be ANOVA. If you have more than one independent variable with at least 2 groups, one independent variable, yeah, more than 2 groups, is going to be factorial ANOVA. Okay, it's going to be factorial ANOVA. It's very simple, very simple. And do not be afraid to have more than one dependent variable. If you are comparing, okay, especially for lab-based, yeah, for lab-based or experimental design, if you are comparing groups, okay, comparison test is often used for experimental design, okay? So if you have more than one independent variable, it's simple, just use MANOVA, okay? You can also use repeated measures MANOVA. We have all that. So you are not, don't feel confined to only using ANOVA, t-test, or regression. No. You can use other analysis, okay? It's not that hard, right?
Dr. Nadia.
Yeah, sorry.
Apa maksud you 2 independent group tu maksudnya an independent that we group into 2 like big group. Okay.
Alright, dia macam ni. 2 independent group are like this. For example, we want to see Hari Raya spending. Okay, so Raya is close by. Okay, we want to see Hari Raya spending, whether it differs between male and female. Okay, yes. And this male and female, they are not related to one another. So we want to see whether our hypothesis is that, female spends higher during Hari Raya. Is it true? So run an independent sample t-test because our respondents here, our sample, they are independent of one another. Okay, they do not depend on one another because they are total strangers, right? We
Mm-hmm.
only take a group of females and we only take a group of males. But if we want to see whether there are significant differences in the spending of husband and wife, okay, because they are related to one another, because they are paired together, we have to use a paired sample T. You see?
Okay.
So sama juga if our group kita nak buat macam ni. We have a supervisor and we have employee. So this supervisor mesti ada dia punya employee, they are related to one another, we have to use paired. Okay, because it's from the same macam kita ambil satu pair. So that's why we use pair. If they are not related to one another, we use independent sample T. Before and after bagaimana? Pair. Okay, because it's the same respondents. For example, we want to see whether a diet pill, whether the effectiveness of a diet pill. Okay, so kita akan measure before and kita akan measure after. It's the same respondents, right? So it's paired sample T.
Okay.
Saya harap saya menjawab soalan.
Dan bila kita nak running these two group ni, maksudnya one of the objective tu mesti untuk maksudnya ada dalam objektif tu ya?
Correct, ada dalam objektif. Because objektif dia macam if you want to test the effectiveness of something or something that you manipulate, okay, kita kena ada stimulus. So you nak test the effectiveness of the stimulus, or you want to test whether there's differences between means. For example lah, sekarang ni we are moving towards ODL and face-to-face. So we can also test whether face-to-face or ODL on the same group of students, which one is more effective. Kalau kita tidak test on the same group of students, then it's going to be independent. Kalau kita test on the same group of students, it's going to be paired. Tapi yes, objektif mesti ada.
Great. Thank you.
Thank you. Alright.
Yeah, Dr. Nadia, you
Saya.
see the questions will be coming soon.
Okay, sure.
You'll be bombarded with the questions, no problem. You can just
No problem, no worries. Okay, I'm just going to finish this very quickly. All right. So we've talked about the ANOVA, we've talked about the t-test, right? So let's go over your favorite test of association. Everyone likes this. I don't know why. Okay. Oh, sorry. When we talk about ANOVA and when we talk about if you have comparison, if you want to compare more than two groups, right? You want to compare more than two groups. Then for ANOVA, you have another follow-up analysis. You have a post-hoc analysis, okay? Okay, and don't be afraid if you are faced with question like, oh, did you run a priori test? Okay. For ANOVA, you can have a priori or you can have a post-hoc. A priori happens before. Okay, you have already predetermined the analysis, the follow-up analysis. Okay, so that's going to be called a priori. A post-hoc is after you run an ANOVA, you saw the results, and then you decide, okay, I need to run a post-hoc on it. Okay, so a priori and a post-hoc. All right, test of associations. As you know, if you want to test relationships, only relationships, yeah, you can use Pearson correlation. So oftentimes I see in thesis, right, people write, oh, I'm going to test my hypothesis using Pearson as well as multiple regression. My question to you is, why on earth would you want to do that? Because multiple linear regression or linear regression will definitely give you the Pearson correlation coefficient.
Yes.
So why would you want to run two separate analyses?
Yep.
Okay, if you run multiple analysis on the same sample, it's going to increase your error. Okay, because we are throwing away our degrees of freedom, DF. Okay, our degrees of freedom, we are throwing it away. So we don't want to do that. We don't want to increase our errors. So just run it once. Okay, it's going to give you the Pearson correlation coefficient anyway. All right. So if you want to predict the value of one variable onto another, like for example, I want to predict I am a restaurant manager. If I want to predict like whether the weather is going to affect my sales, okay, I can use simple linear regression. I don't need to use SPSS for that. I can use Excel for that. Okay, it's fairly very simple, right? It has a predictive purpose. Okay, if you have a binary dependent variable, so if your dependent variable is the dichotomous, for example, you want to see if service quality leads to revisit intention, and this revisit intention is only measured using yes or no, whether the customer will revisit or not. Okay, yes and no, tu saja dia punya scale. Then you have to use logistic regression. Okay, it's a little bit hard to interpret logistic regression tapi nak run dia tak susah. Okay, so jangan takut. So if you want to assess relationship between two categorical variable, you only have chi-square, nothing else. Okay, chi-square saja. And we also have other analysis which I don't include here. Those are advanced analysis like multi-dimensional scaling, like discriminant analysis, like cluster analysis and things like that. Mankova, MANOVA, I don't include it here because they are a little bit advanced, like structural equation modeling and whatnot, okay? All right. So I'm done with my sharing session. I welcome questions from you guys.
Okay, thank you, Dr. Nadia.